Hello madam, my name is Yap Wei Hao, the leader from Group 5. This video is presented by Yap Wei Hao, that's me, Lo Wei Hong, Tan Sek Hui and Brandon Ang. Hope you enjoy this video. Thank you.
Hi madam, I'm Tan Sek Hui from Section 2 Group 11.
Hello madam, I'm Brandon Ang from Section 2 Group 11.
Hello everyone, I'm Lo Wei Hong and we are from Group 11, and today we are going to present about the VCO, Voltage Control Oscillator.
Alright, the content layout is the introduction of the VCO, block diagram and circuit, operations, formula and applications of VCO, right? So first of all, I will talk about the types of VCO. And there are two types of VCO oscillator, which are the harmonic oscillator and the relaxation oscillators. And there are some examples for the harmonic oscillator, such as RC oscillator, LC oscillator, and crystal oscillator. And we have to know the difference between the harmonic and relaxation oscillator. So the harmonic oscillator will provide the output signal in sinusoidal waveform. Meanwhile, the relaxation oscillator will provide the output signal in either square waveform or triangular waveform. And we used to call it as sawtooth waveform as well for the triangular waveform. A voltage control oscillator with an output signal whose output can be varied over range, and it is controlled by the input DC voltage. The output frequency is actually directly related to the voltage of its input. And the frequency can be varied from few hertz to hundreds of gigahertz. By varying the input DC voltage, the frequency of the signal produced is adjusted. Output frequency depends on time of charging or discharging of the capacitor. This is the capacitor. VCO provides a varying output signal, which can be in sinusoidal or non-sinusoidal. And the example is the 566 IC unit, and such as the LM566 and NE566. And the LM566 is specified for operations over 0 degrees Celsius to 70 degrees Celsius temperature only. This is the pin configurations. Pin 3 will provide the square wave output. Pin 4 provides the triangular wave output, and pin 5 is connected to the modulation input. And this is the VCO circuit diagram. This is the block diagram of VCO, and this is the external capacitor and resistor. This PUT, programmable unit junction transistor, right? This is here, and this is connected parallel to the feedback circuits. This is the feedback circuit, and this is PUT. This is how the PUT look in the reality. That's all for my part. Thank you.
Now let us go through the operation of circuit. There are three types of voltage control oscillator. The first type is using two operation amplifier. Second type is using PUT, which is programmer uni-junction transistor. The third type is using 566 IC. So this is the circuit diagram for VCO using 2 ohm. In this circuit diagram got 2 ohm. The first ohm function as integrator. Second ohm function as schemic trigger. When MOSFET is on, the current from R1 flow through the MOSFET, and then the voltage is converted into the current signal. Charge the capacitor. When MOSFET is off, the current flow from IR1 discharge the capacitor. For the first output of the waveform is triangular waveform. M2, which is schemic trigger, accept the triangular waveform as input from first ohm. Vin is smaller than the threshold level. The output 2 is equals to 0. Square wave is formed. This is the second type of VCO using PUT. PUT has three terminals: anode, cathode, and gate. This is gate. This is anode. and this is cathode. In this circuit diagram, PUT is in on condition. Current is flow through. When PUT turn on, capacitor discharge until the ramp falls below the PUT forward voltage. This causes the PUT to turn off and the capacitor begin to charge again and generating a new output ramp. The sawtooth amplitude and period can be adjusted by verifying the PUT gate Vp. Thus, the capacitor rapidly discharges when PUT is turned on. This is the third type of VCO by using 566 IC. It can generate both square wave and triangular wave signal. 566 IC contains current source to charge and discharge the external capacitor C1 at a rate set by external resistor R1 and the modulating DC input voltage. A schematic trigger circuit is used to switch the current source between charging and discharging the capacitor C1. R1 and C1 function as timing component. C2 is used to prevent the parasitic oscillation during VCO switching. Then the R3 is function as providing the control voltage VC. Triangle and square wave output are obtained from pin 4 and pin 3.
Hello madam, my name is Yawei Hao. Today I'm going to discuss about the importance formula for VCO. First, I'm going to discuss about VCO by using put. As you can see, the frequency of oscillation is equal to Vin divided by Ri times C times 1 over V peak minus forward voltage. This is the circuit for VCO by using put. Next, I'm going to discuss about VCO by using 566. FO equals to center operating frequency and V plus equals to positive voltage. 566 VCO produces two waveforms, which are square waveform and triangular waveform. Next is about VCO by using two OPMs. These are the importance formula, and FT represents as instantaneous frequency of oscillator. K represents as gain, and this is a circuit for VCO by using 2 OPM. Next, I'm going to discuss about the applications of voltage control oscillator. The first application is audio frequency VCO. Audio frequency VCO is used in analog music synthesizers, and audio frequency VCO was lastly used in 19th century due to their output stability in the face of temperature changes during operation. Since 19th, the musical software has become the dominant sound generating method because audio frequency VCO has their natural imperfection. This is the VCO, audio frequency VCO, which is used in the musical software. Next is 566 generator. So basically, an E566 will be used in this function generator. The VCO can control the frequencies of output with the amplitude of an input voltage signal. Thus, it can be programmed over a 10:1 frequency range. By proper sections of internal resistance, it produces two waveforms, which are triangular waveform and square waveform, from 1 Hz to 1 MHz. Its duty cycle also offers a wide range of generated signals. I think that's all from me. Thank you.
Hi, my name is Brandon. Today I'm going to talk about some of the application of voltage control oscillator. One of the application is phase lock loop. What is phase lock loop? Phase lock loop is a control system that generates an output signal which the phase is related to the phase of input signal. And then this phase lock loop, it consists of three basic elements, which is phase comparator, voltage control oscillator, and loop filter. Look at the diagram here. We also have voltage control oscillator, loop filter, phase detector. Here, phase detector and phase comparator is the same thing. You can call it phase comparator or phase detector. So VCO is the key within a phase lock loop, which means voltage control oscillator is the main thing and the most important one among these three in order to build a phase lock loop. So you can see based on this diagram. Okay, next we have electronic jamming equipment. What is electronic jamming equipment? For your information, electronic jamming equipment is a transmission of electronic signal which disrupts the communication signal. The unintentional jamming occurs when the operators transmit signal on a busy frequency or it radiates a signal. It can be used in wireless data network to prevent the information flow. Okay, for example, whoever out there they want to break in to steal your information. So you need to have this jamming operation to prevent them from stealing. How do you prevent it? It's like this jamming operation sends an additional signal which is the same frequency with the signal so that it overpower the signal and it make the signal display to become confused and is unable to be read. So the people out there who want to steal the information, they can't have the proper signal. The signal is cannot be read, so they're unable to steal the information so that our information can be kept safe. I think that's all from me, and this is the end of my lecture, and thank you.
Okay, that's all from us, madam. Thank you.